Oh, hello everyone. My name is Jordan. I'm with Collabora, and I'm going to talk about the update on encrypted media extensions in GStreamer. Yep. So about me, working at Collabora since 2022, primarily on GStreamer projects. Before that, I worked at Amazon Video for a while, and then before that, I worked for smaller companies. Sometimes mainly startup type size companies. And I've done things like digital printing automation, some GStreamer work a long time ago. Before that, I've done a little bit in Linux audio world as well, and then a lot of traditional web service stuff, like backend stuff as well. Yeah, currently based in Fort Collins, Colorado, in USA. Yeah, that's pretty much all there is to say about me. So we're going to talk about today is first a little bit of a review or introduction on what EME is, and also going to talk about just get a picture of what they are and the overall kind of concepts as well, like the software concepts, and then also what I implemented and I presented last year, and what are the shortcomings to that and what I've done to make some improvements to it, and then also what's gonna be upcoming. So, all right. So the introduction is okay. So what is it? So basically, it's for web browsers to play encrypted media. You gotta have some kind of things in place to do that. So in general, commercial entities, they want to protect their media from users taking it away from them, playing it in ways that they don't want to play it. So in the end, that results in basically hiding information from the users. So that's basically what a content decryption module does. It's able to decrypt this stuff without letting the users find out what's inside of it. The standard itself generally supports two formats of video, which is MP4 containers and WebM containers. The actual streams inside those containers, they employ the common encryption scheme, which is basically a way of encrypting something and also allowing multiple CDMs to decrypt it. So imagine there is inside the standard itself, there is something called clear key, which isn't really doesn't protect the data. It just encrypts it, and you put keys that you know in there. So you can use the clear, for one example, you can use clear key, and you could also use a commercial CDM to decode the same video. So you distribute one video, and you can decrypt it with multiple ones. So there are multiple proprietary ones, like some ones from Microsoft and Apple as well. So you want to use the same video and just use. Be able to support it on multiple devices, stuff like that. And obviously, the web browsers that you use today, Firefox or Chrome, they also include one called Widevine, and I've integrated that one also for the demo I did last year. So the underlying concepts here, there's a couple different things. These are the main ones. So there's something called media key system access, which is kind of like a level of indirection around the actual keys, saying, "Give me something that can work with this system," and then the media keys are actually what you get out of it, and that's the actual key system. So imagine like Widevine or something like that. That's just an interface to that. The session is what happens. Is basically the current context that you need to decrypt something. So you will need like a key or a group of keys, depending on what the actual media is. Yeah, so with all these things together, you can, it kind of provides you the framework of decrypting media without actually being too prescriptive of what the rest of the design is. So this is kind of how they fit together. The application has a media player inside of it, or multiple media players. The media player has access to the media keys, and the media keys kind of links. It kind of is a kind of interface with the actual CDM itself, and the media player integrates the decryptor, which gets the keys it needs from the CDM, basically. Or sorry, it puts the keys. It gets keys from the CDM or whatever piece of information it needs to decrypt the media. That's kind of how they fit together, from components perspective. How actual data flows here is that basically whenever encrypted content is encountered, the application is responsible for basically contacting the license authority and providing the information that the rest of the system needs to decrypt it. This is all basically part of the specification, and this is the typical model used to do this. So the application, so once the application gets a response, it feeds the session with the response, and then that allows the CDM to do what it needs to do. And then as the media player is processing content, it decrypts what it finds. It basically asks the CDM to decrypt what it finds. So if you want to know what can GStreamer do right now, the current state of GStreamer, it doesn't really have a lot in it itself. All it knows how to do is identify that there is protected media, and let the application somehow figure out how to handle it. There isn't really a built-in decryptor element yet, although that's something I've implemented. And there's actually one in WebKit as well. So let's see. So basically what happens is as the MP4 or whatever is being processed by GStreamer, it's going to look into the debuxer basically learns that it's encrypted, and it lets the rest of the stream know about it and the application as well. So the first thing done is implement a library. So this allows basically anybody who wants to integrate a CDM into GStreamer. So all it really is those interfaces that we talked about. They're just a bunch of abstract concepts that allow you to hook into the system. So anything that adheres to those interfaces can act as an EME implementation. There's one bit of kind of ambiguity is how do you actually load a CDM? So the way that I implemented that was there's an actual kind of like a fake element that you load, and then you request the CDM from there. So that's just a little detail, but yeah. So after all that's in place, you want to actually get a real implementation, something that can actually hook into basically what's in your web browser right now. The way I did that was basically assume you have a web browser installed, look around on your computer for that binary, and write a little decryptor that wraps that binary at runtime, and basically do the decryption. So it's like a little bit of reverse engineering, but actually it's not that hard, because if you look at the Firefox source code or Chrome, they have a C++ header that actually describes the interface, so you can get away with that. So you just got to load it at runtime, and you can talk to it. It has a lot of interesting kind of like asynchronous aspects to it, but you can work around that. So once you have all that in place, what do you actually have to do to integrate it with your application? It's actually fairly complicated, which is why you have to do a little bit more work. So you really got to set up a pipeline, make the protection systems, and then hook into the bus, and basically watch for events and react to them. Talk to the server and stuff like that. So you have to do all this stuff. So it's fairly complicated, and make that easier. So what have I done to make it easier? Oh, sorry. So basically all these things you have to do, and you have to learn all these, it's pretty complicated. And so the thing is, what do you want to do? You want to take a couple steps out of there, let people evaluate it pretty quickly. So right now, before what I did, you have to write basically an application to do this. Now you could just write a kind of like a GST launch line and get some stuff decrypted. Yeah, so the way I did it is I just created a little helper bin that wraps the actual decryption with the most typical communications patterns that EME kind of describes. And what this does is it actually lets you decrypt content automatically without any interaction by an application or without writing any code in the most common cases. Also, you can customize it to kind of make some adjustments. You want to test certain things out, change the keys, change the server, whatever. So you can just set a couple properties on these elements and then do that. So it can work. You can just make a GST launch line and test it out. Let's see. So the status is right now it's in a draft merge request that I'm pointing to. And let's see. Yeah. So the next steps I want to do is actually do secure, do a real CDM. That's basically like what you'd have basically what you have on your phone. So like that. So a trusted execution environment on your phone, and basically integrate that. That's kind of what I want to do next. And that'll just enable a lot more deployments of this. So one thing I can do is show a demo of this bin. Let's see. It's very similar visually to what I've demoed in the past, but you can see it actually running on multiple systems. Basically, you can do it on Widevine. You could do it on ClearKey. So here's one example script on ClearKey. This is just basically a GST launch command. What this does is it actually makes an MP4 file look like a dash file, because dash contains some extra metadata that helps you decode the media. Basically telling you what URL to contact and that kind of stuff. So this EME OpenCDM bin basically just kind of makes something else look like a dash file that has extra information that simplifies the whole thing for anyone who wants to decrypt something. So here's one example with ClearKey, and I'm going to play it back extra fast so you can see that it fails or it pauses when it's trying to contact the server and it's waiting for an answer. So you can't, it's stuck at that point. So let's see what goes on here. So yeah, it gets stuck here and then it continues and it decrypts the whole thing. The beginning of this is actually not encrypted, so that's how you can get away with that. I can do the same thing with Widevine. You'll see some more log messages here to show you that it's Widevine. Let's try that again. Yeah, so you see these messages coming out of the Widevine CDM. And the same kind of thing. It gets stuck, and and it continues as once it gets a response. And if you just get rid of some parameters, you can see that normally it'll play back in real time, and the response will come in on time, and then there's no interruption. Let's see. Yeah, so I think at 10 seconds is when the actual stuff is encrypted. So yeah, so this is all encrypted media playing back with no application code, just GST launch. Oops, sorry. Yes, that's pretty much the whole presentation. Does anybody have any questions?
Thank you for your presentation, and I am wondering if it is applicable for the Widevine level 1, which is a hardware DRM.
Yeah, sorry. It's the level 1 is the least secure. Is that the? I always forget the direction. Most secure. Yeah, so the most secure. Sorry. So that's something we have to do with the trusted execution environment. This is using the web browser one. So is that 3 or something?
Yeah.
Okay, yeah. That's what this one is doing. So yeah.
Okay, thank you.
Questions?
Thank you for the presentation. Yeah, I was wondering the same. I also have the same problem about the L1 and L3, but I wanted to ask you if you have some insights about the trusted execution environment and how it can work out on Linux and especially on GStreamer. If you have any other information or something like that. Yeah,
well, I think the immediate goal is actually to do it on Android. So That's what we're gonna. Yeah, I think Olivier knows more.
Yes.
about this, yeah.
So on Linux, the problem is there's no one single interface. This is something that's being discussed also with kernel people and stuff. So there are some interfaces to opti and stuff that are defined, but like there's like a missing middle layer, and that is being worked on. But the goal is with an Android is to demonstrate that the GStreamer part works at least, and then we can like close the little gap in between that's missing. Like Whitevine, you can get from Linaro if you sign all the right NDAs. They have that, but we have like the little missing bit. There's OpenCDM from the RDK people, but I don't know if that's the future. Well, it might be, might not be. I don't know. Maybe the Igalia guys know because I know that they've worked on that.
Hi. I understood that the current plan is continue with Android development and the trusted environment, but is there future plans to also support Apple's and fair play encryption?
I mean, nothing prevents you from doing that. Other than Apple, I guess. But yeah, so what I have right there is actually pluggable. So there is actually a separate plugin system, which was actually if you've ever seen on GitHub, there's a project called Sparkle CDM. So that is actually this actually makes use of that. So anything that implements OpenCDM can be loaded right in here. At the same time, you can write your own. As I said, there's a bunch of interfaces. So you implement those interfaces with whatever you get from Apple, and it will hook into GStreamer. So you have a couple of paths to integrate. Mm-hmm.